have another function for you, and this one's the easy one. Maybe it's a function. Let's see. All right. Y equals 1. Does everybody know what that looks like? It is a line. What's its slope?
0.
Has a slope of 0. Does it pass the vertical line test?
Yes.
Most definitely. In fact, this is the most predictable relation you can ever have. Not only do you know what you're going to get, you always know what you're going to get, don't you? This is the dollar store, right? You go in, how much does it cost? It costs $1.
Yeah.
Right? This is called a constant function. They're extremely boring, but they're functions, okay? So what's the domain?
0.
Nope. Well, that's part of it. Nope. You have the right idea, but you're thinking backwards. The domain is all the x values. Does it say anything about x?
No.
X can be anything you want. In fact, can't they put any product they want in the store?
Yeah.
They can put in any product they want. It's okay. What's the range? 1. Pretty limited, huh? That's a very limited range. The domain is all real numbers, and the range is 1. Here it is. It's called a constant function. And yes, it is a function. It passes the vertical line test. Here it goes. Something that's not, and by the way, that's f of x, by the way, too. F of x equals 1, same thing. One last one, and this is called a constant function, this particular one. There's one more, and this is called a one-to-one function. Think about what that sounds like. If I put in one x value, what do I get?
1 y value.
One unique y value.
Should be a point.
It is a point, that's right, that's always true. We always get points. But here's how you can tell if something's a one-to-one. It should work both ways. It doesn't work with these, right? Because if I tell you a price, you can't automatically tell me the product, can you? Do y'all see that that's not one-to-one? One-to-one is the situation where you go to the car lot, you go to a used car lot, and every car has a different price. If I tell you the price, can you tell me the car?
No.
Yeah. Oh, yeah.
If every car has a different price, yeah. It works both ways, doesn't it? Everybody get that one-to-one? But if you go to a new car lot, all the prices are the same, basically. $89.99, right? Or $13,999. You see what I mean? It doesn't work there. But at a used car lot, maybe they can get a different price for every car because they have different values. Is that clear? All right. That's a one-to-one function. Almost every single line is a one-to-one function because they pass the vertical line test and the horizontal line test. You see, you got to check a horizontal line to see if it'll work the other direction. Here's what I mean. Here's the vertical line test. Doesn't the black one pass the vertical line test? That's because y equals x squared is a function. The blue one does not, does it? It does not work both ways. Does everybody see that a vertical line, when you take the inverse, becomes a horizontal line? So to be a one-to-one function, it has to work both ways. It has to work horizontally and vertically. And lines always work, almost. Here's a one-to-one function. f of x equals 3x plus 2. Go ahead and draw the picture of it. What's the y-intercept?
2.
Nope.
0, 2.
What is it? 0, 2, thank you. And the slope? 3 over 1, 1, 2, 3 over 1. Pretty steep line, looks something like this. The x values can be anything. That means the domain is all real numbers. How about the range? Can y be anything? That's what those little arrows mean, right? Keeps going forever in both directions. Keeps going forever in both directions. X can be anything, y can be anything. Does it pass the vertical line test?
Yes.
Definitely. Does it pass the horizontal line test? Then it's a one-to-one function. It works both ways. If I take the reflection of this thing, by the way, it just goes this way, doesn't it? If I take the reflection of that, it's going to be a function too. It works both ways. All lines do that, except vertical lines are not functions. They're almost anti-functions. They're the exact opposite. It's kind of like going to the dollar store and saying, well, I paid $1 for this. What is it? I don't know. Right? See what I mean? You can't say, oh, I paid $1, so what product did I buy? Well, I don't know. I have no idea. This will be important, and I'll be able to describe that importance to you more tomorrow, or the next class period when we have class again, which will be on Monday. So when we come back to class on Monday, what we're going to do is we're going to do what mathematicians and scientists do. And the whole purpose of math is to take a whole bunch of data. Isn't that what scientists do? They collect data? And then they analyze it. But they analyze it for a very specific reason. Did anybody see the movie about tornadoes? What was the name of that thing? Twister, yeah. Anybody see that movie? Okay. What did he want to do with all of those sensors? And he kept trying to get the sensors to get pulled up, right? And he couldn't get them to work. What did he want to do?
He was trying to see what direction.
He wanted to get wind direction, speed. He wanted to get data, right? Remember, he kept saying all about, I want to collect data. But there was a purpose in mind. He didn't just want the data for no reason. There was a reason he wanted to collect the data. What did he want to do with the data?
Figure out where it was going.
To do what?
Figure out where it was going.
Where it was going and what's going to happen. He wanted to be able to predict when tornadoes would occur before they happened, right? That's the fundamental purpose of almost all scientific endeavor, is to make predictions. We want to know, is this person going to get cancer? Wouldn't that be nice to know? How about this person is going to develop diabetes before they get it? Right? By the way, we're able to do that now. If somebody's 300 pounds and 5 feet tall, they're going to get diabetes. Do y'all see what I mean about making predictions, though? That's the point. And it comes back to our definition. What is a function? Predictable relation. And the big part of this is the predictable part. You see, we want to be able to make predictions that are accurate. By the way, if you could make a prediction, an accurate prediction on what's going to happen in the stock market, you could become a millionaire overnight. If you knew for certain that a specific stock was going to go up or down, that's all you need to know.